Hello everyone. In this video, I'm going to implement 4x4 multiplier using FPGA. So our first step will be creating a new project, and then we're gonna pick the place where we should save it. Let's go here. You can download, create a new project, file, call it homework 3 multiplier. Alright. So I'm gonna pick this folder. Then I'll give the project a name so we can start with it. After that, I will start with empty project, and then I'll leave this blank. I will add the project later. I will pick the board that we are dealing with. It's the one sock board. Put it in the name folder. I'll choose this available device after I make sure that I'm choosing the second one. Alright. So for the simulation part, I'll choose Altera, models in Altera, and then I'll review all the information should be correct. Now press. Right now we have two ways to create the multiplier. One of the most important ways that you are going to use is using the intercultural program software, which has several libraries, basic functions, DSPs, interface protocols. So for my case, I will go with the basic one, functions, arithmetic, and I'll take LPM multiplier. Double click on it, give it a name. It's going to be the same name that we have gave to our project, mult, and I'll go with the HDL programming language. Next. So it will open a wizard. It will give us like a graphical user interface that we should give the parameters, all the parameters to the multipliers. So our first thing we need to do is give it the weight. So for our case, I'll go with 4-bit for the data A and 4-bit for the data B, and the width of the output will be like 8. I'll click next. Now this window shows what is the data B input and what is the multiplication type. So for our homework, we will go with unsigned, and for the implementation we'll use the default implementation, and that's it. So I'm going to keep this window as it is. Next. So here's pipelining. We are not going to put pipelining on it, so give this pick no. For our optimization, I'm going to choose the default one because we don't need to verify the speed or area and test all these optimizations. So I'll click next. I'll generate a netlist for the design because this is very important. It will give me the timing and the size of the design, the speed, everything I need to complete the compilation. And I will need the VHDL code inside of Quartus prime symbol. Fine, that's it. I'm gonna click on next. Then it will generate the multiplier using the libraries that's already on Quartus. And after that, after it's generated, I'll go to files. I'm gonna find it here, and here we are. So everything is good. Then I'm gonna make this design as set it as top level entry. After that, I'm going to create an SDC file, synopsis design constraint file, and I'm going to bring it from the lab itself, from the properties. So we went through all these steps, and our next step will be creating the constraint files. So I'm gonna copy this one and paste it. Okay, and save it. Give it the exact same name that we have for the project, which is homework 3 multiplier. Okay, save. So after we finish this, our next step will be assigning the pin assignment. We're gonna give for A from switch 0 to switch 3 to B, sorry, and for A we are going to set switch 9 to switch 6. So to do, we can do this after So we need first to run the program. So we have, because if you go here for the assignment editor, you will find it empty. So we need to run the program first. So I'll come back once we finish the entire compilation process for the design. So while we are doing this, I'm going to prepare all the pin assignment that we need for the switches and for the lids. So we're going to keep this window appear. So as we mentioned, while it's finished, as we mentioned, we will go through the entire process and we will set the zeros from switches from 0 to 3 to the data B and switches from 6 to 9 to that. All right, so analysis and surfaces is done right now. Sometimes it takes a long time to finish the filter based on the quality of your PC and how long it's been. So it's gonna take for my case, it's gonna take some time. All right, so right now we have finished compiling the design. So if we go to the assignment editor, we will find like nothing here. So we need to go to the programmer and to see that's it. So as you can see here, we have data 3A and data 1. We need to assign some values to it, and this is the reason. So for this case, we'll go to the data. So for data A, we'll assign from switch 6 to switch 9 the value. All right. So for data A0, we'll go with switch 6, which is following this just to make it clear. So for switch 6, we will go with AE 11. AE 11. Press enter. And for switch 1, data A1, we'll go with 7. So AC 9. Enter. And for data 2, AV 10. AV 10. Good. And for data 3, we'll go with switch 9, which is AE 12. Good. And for data B, we'll go with the switch 0, which is AV 12. And for data 1, we'll go with the switch 1, which is AC 12. And for the rest, AF 9. And for the last one, is it AF? Good. Now we have finished with the inputs. Let's go to the output, the H1, which is we need to assign for them switch 0 to 7 should be go to loop 0. Okay. So for the lids, we are going with 0, which is V16. For 1, it's W16. For 2, it's V17. And for 3, it's V18. And for 4, it's W17. And for 5, it's W19. For 6, there is Y19. And the last one is 7 will be W20. Okay, good. After we finish setting all the pin assignment to the inputs and the outputs, I'm going to close this one and recompile the design again so we can get the assignment ready to be prototyped to the applicable. So I will come back when this is finished. After we finish the compiling design, right now our next step is going to the programmer. Now it's going to take some time to work with it. So as we can see here, this is the programmer. We first of all we want to make sure that the hardware of the FPGA is connected to the PC. After that, we're gonna use the device, choosing the second device, and we will get this. We don't move this, and we will add a file which is the string file. We should find it here, the inputs. So this is the SOR file. All right, and once I hit the start button, it should be working now on the FPGA. So once I hit the start, this is the FPGA right here, as we can see here. So the first 4 switches is for A, and the last 4 switches is for B. Let's test the design. So if we give it like, this is 15 for A, and this is 15 for B. I think in this case we should go to 25. So for our case, in this case, I think I have some problem with the pin. Sorry about that. So for my case, I think it's working perfectly. So if we give like FFF 15 for the design, and we multiply it by 15, we'll get in binary here 255, which is the exact same number. Like if we go with, we put all of these like ones, we will get, this is 15 multiplied by 1 will give us 15. And thank you so much.